Welcome and hello. This is a video exercise using HEC ResSim. And in this exercise, I'm going to be discussing tandem release rules. This is part two of a on tandem release rules. If you haven't watched the previous exercise, the previous video, I'd recommend that, but it's not necessary. What I'm going to do in this exercise is talk about explicit system storage balance as opposed to implicit. So if you're excited about this topic like I am, then let's get rolling. All right, so I have HEC ResSim up on the screen here. I'm going to, like all the exercises, take you through the steps one by one so you can see everything on the screen, and we'll get started with creating a file new watershed. You have to be in the watershed setup module for that option. So select watershed setup module, file new watershed, and then I'm going to give the watershed a name. And then we'll select the directory we want that watershed directory to be created in, units, and time zone. Apply, okay, okay, and okay. Our watershed's created. Let's go ahead and zoom in a little bit and select the stream alignment tool. Hold down Control, start clicking to generate a stream alignment on the map. And then just before your last click, go ahead and release Control. Then it'll ask you for your stream alignment name after you do your final click. And let's go ahead and add a computation point here, CP1, and a reservoir. To create a reservoir, you select the reservoir tool, hold down Control on the upstream end of the reservoir pool, single left click, let go of Control, and then click single left click again downstream on the stream alignment. We'll call this reservoir north. Okay. And then what's just below that, let's do a reservoir south. Okay. And then let's do one computation point at the downstream end. So I select the computation point tool, hold down Control, single left click, and then give it a name. I'll call it CP6. So they are in order 1 through 6, upstream to downstream. The downstream stationing here is 0, and then upstream is whatever it is. All right, so I'm going to go up to Watershed and Configuration Editor. Let's go ahead and go Configuration New. I'm just going to go ahead and call it Config 1. And then call it a time step of 1 hour. This is not even used by ResSim. Apply, and let's confirm that I spelled reservoir right. I didn't. Let me correct that real quick. And I also want to make sure the reservoirs are in the configuration. They are. Okay. Rename reservoir. Okay. Okay, so let's go ahead and save the watershed and move on to the reservoir network module. All right, the first thing we want to do is create the network so we see our reservoirs pop up into place. And to do so, we'll assign the configuration to config 1. So we don't have to build the junctions or the reservoirs. We've already done that. It's based on that configuration. So when we click new, our projects pop into place here. And then let's click the stream alignment, the reach tool here on the left. Hold down the Control key and then single left click on the upstream junction, let go of Control, and then single left click on the next adjacent downstream junction. And then give that reach a name. I'm just going to go with the name it suggests, and then do that a couple more times to connect the network. Okay, network's connected. I'm going to give it a save. Now I'm going to select the junction tool and add inflow to this CP1, this upstream most junction in my network. So I'm going to click Edit Junction Properties and then Local Flow. I'm going to call this inflow at CP1 with a factor of 1. So it's just multiplied by 1. There's no multiply factor involved. This is not the actual time series. What you may be wondering about is the actual flow in CFS or CMS into this junction. And let's go ahead and do that now. Once I create an alternative, I will assign that time series data set to this inflow at CP1, and then the simulation will use that information from the alternative to actually compute. Okay, so I'll click apply here and then okay. Now, to create that time series data set that represents the flow at CP1 entering the network, I'm going to go ahead and click Tools, HEC DSS View. DSS is the sort of the database system for these HEC programs. And I'm going to go File, New, and we'll just create the DSS file here. I'll just call it time series data. Okay. Okay. The file's created. I'm then going to go up to manually create a time series. Yep. Now I'm going to fill in this file name parts up here. I'll just be very generic and call it project, location. This is the C is the parameter, so I'll just call it flow or inflow. And then 1 hour. Yes, that's what I want to use. There's other options. And then for F, it's sort of a user field. I'll just call it 10,000 because it's going to be a constant 10,000 CFS for the month of the simulation. It's going to be a month-long simulation, and let's use the month of June 2024. So I'm going to type in 01 June 2024, the first hour, and CFS. Instantaneous value is fine. And then I'm going to click this automatic generation tab and then fill in the values. It'll be a constant 10,000 CFS. And I also have to do the end date time, which will be the end of the month, 30 June 2024 at the 24th hour. And let's see, if I click off of that or just tab to the next field, I can click this generate button. So I do that. The numbers are generated. Here's the 10,000 CFS. And I should have 720 hours of data, and I do. So that looks good. I'll click save, and then no, I don't need to return to the edit screen. And we are good. We've got our time series data set created right here. If you can tell, it's just a blue line solid across at that 10,000 CFS for the entire month of June 2024. Let's go ahead and edit our reservoirs now. We're still in the reservoir network module. So I click the reservoir tool, or you can click the generic mouse pointer tool, but right click on the reservoir, edit reservoir properties. Another way to enter the reservoir editor is to come up here and just say edit and then reservoirs. And then like when you do that, you have your choice of which reservoir you want to edit. So that's just a different door to get in the same place of editing. I'm going to go ahead and rename these dams as just dam because that's just my personal preference. And then I'll do the same thing with the south reservoir. That's certainly not necessary, doesn't affect the simulation or anything. But if you had multiple dams, maybe that's important to you. Okay, so I'm going to go ahead and start by defining the reservoir geometry. I click on the pool here. All right, so I'm pasting in some numbers here. My reservoir has a total capacity of 50,000 acre feet. And to keep things simple, I'm just going to have the north and south reservoir with the same properties. So I'm going to click apply here, head over to the south reservoir, click pool, and then paste in the same numbers. All right, 50,000 acre feet. So these are two reservoirs in series on the same river, and they have the same properties, the same volume, the same storage, just to keep that consistent. So I'll click apply. And then back at the north reservoir, we have our pool already. And now let's go ahead and click on dam. I'm going to say that elevation of the top of the dam is 1,500. I'll say the length of the dam is 1,000. And now I'm going to add an outlet. We'll call it a controlled outlet. Okay, so I'm pasting in the controlled outlet. It has an invert at 1350. And it can, let's see, the max CFS is 50,000 CFS. So there's plenty of outlet capacity. I'm just going to increase that to be safe for 3 gates. So that multiplied. And then I'm going to do the same thing over at the south reservoir. Click apply, south reservoir, dam, type in my numbers that I use for the north reservoir here. And then I'm going to add a controlled outlet, paste in the same numbers, and say there are 3 gates with those exact same max capacity release. All the other features associated with the dam and the controlled outlet, I'm just going to leave as default. So I'll click apply and then head over to the operations tab. This is where we create zones and operation sets. So I'm going to say operation new. I'll just call this operation set 1. Okay. And it gives me the 3 default zones. So I'm going to just type in constant values to sort of keep things simple. The flood control will be at the top, and then click apply. conservation is going to be, let's do 1480 feet. And then inactive will be the bottom. That'll be 1350. Apply. So if I double click on the plot, you can kind of see the zones. We got the conservation zone here. We got the flood control zone up here. Okay, I'm going to do the same thing for the north reservoir. So operations set, operations new, operations set 1. Okay, 1500, 1480, apply. Inactive is going to be 1350, apply. Okay, and that looks just like the south reservoir, so that looks good. Okay, now I want to add a couple rules. And the first one is going to be a downstream minimum flow out of the south reservoir. So it's going to be, I'm going to go ahead and add a rule. It's going to say min, and we'll go with 13,000 CFS. It's going to be a release function rule out of the controlled outlet. So I'm going to select define, use date, that's the default, and then just say 13,000 all year long. So apply. Oops, I have to say it's minimum. Apply. Okay. Now, if you remember, we're going to have 10,000 CFS entering the network and an expected 13,000 leaving the network at a minimum. So we're going to experience a shortage, and that's what I want. Let's add rule to all zones, apply, and this is only for the south reservoir. The north reservoir, we're going to add a rule, but this is our tandem rule. So I'm going to go add new rule. I'll just call it tandem, and then I have to say the reservoir. I can't say the dam or the controlled outlet. So we have our tandem operations here. Okay. And then I select my downstream reservoir. It's reservoir south. It's the only one there is. And then click apply. And I also want to apply this to all the zones. Hold on. All the zones. There we go. Okay. And okay. All right. Let's go ahead and create an alternative. We've got the reservoir set up with what we need. I'll say alternative new. This is going to be called implicit. And then okay. And we'll use 1 hour for our time step. I'm in the run control tab here. Over in the operations tab, I have to identify the operations set. So we've done that. The look back is how we initialize some of the parameters in the network. So it's asking for the elevation of the pool for both reservoirs. And the guide curve elevation is 1480, and that's where we want to start it. So I'll say 1480 for those two. And then the initial release we'll say it's 13. So we'll say it's 11,500. So that splits the difference. They, sorry. Yeah. And then the downstream, the south reservoir will be flowing 13,000 because that's the minimum. All right. So let's go ahead and hit alternative save. Oh, got to do the time series part details. So I'm going to click the time series row for our CP a 1 inflow, and then click this select DSS path button. Navigate to that DSS time series data that we created earlier in the exercise. Click open, and then select our inflow, and then click this button down here, set path name. So before I click that button, you see it's still not assigned. And let's see if I can get these both in the same screen. Kind of. Yeah. And then I'll click the set path button, 3, 2, 1, click, and then it pops into place. So just so you know, I'm making that assignment when I click the set path name button. All right, alternative save. Let's close that and let me save the network and head over to the simulation module. All right, so we don't have anything on the screen right now, and that's fine. What we need to do is click new and then create a simulation. All right, so from earlier, we were using the month of June 2024. So I'm going to do the same thing here. I'm going to say June 2024. It's going to start on the second hour because the look back will be for the first hour. So that'll be 100 hours. And then the end date will be, we could do the end of the month. I don't think we need that much time though. So let's just do, say, June 20th. And we can come back and change the end date for the simulation later if we need to adjust it. All right, so I'm going to select the alternative that's called implicit and then click OK. That loaded in fine. And now we see our reservoir network pop into the map. And let's go ahead and run it. Okay, let's go ahead and click close and let's view the results by doing a right click on the reservoir and see what the reservoir results look like. So I click plot and let me go full screen here. What I've noticed in the previous lesson and this one too is we have a lot of noise for the first hour or so. So I'm going to actually just take this zoom tool and kind of zoom in on the data that I'm more interested in. Okay, so I've zoomed in and now I'm going to identify that this bottom plot is the flow and it's the inflow to the north reservoir. So we have our 10,000 CFS flowing into the north reservoir and it's releasing 11,500 CFS. So it's sort of splitting the load and splitting the shortage with the south reservoir to satisfy that downstream minimum flow requirement of 13,000 CFS. So what we're seeing here is, yeah, a deficit of 1,500 CFS for 8.5 days almost. And then understandably, when the outflow exceeds your inflow, the storage is going to drop, the elevation in the reservoir is going to drop, and that's what we're seeing in this top plot. All right, let me go ahead and take a quick peek at the south reservoir. So plot. Okay, I went full screen and I zoomed in on our area of interest. And what I'm highlighting here now in this black color is the inflow, which is the exact same as the outflow from the north reservoir of the previous plot we were just looking at. So that should look familiar. The green line here is the release or the outflow from the south reservoir. And as you can imagine, that 13,000 CFS is satisfied for 8 days plus another like 8 hours or so. And the top plot here showing the elevation versus time looks exactly the same as our north reservoir. Okay, so that's implicit system storage balance. What I want to do now is create a trial based on that alternative we just ran. And I want to prioritize the storage of water in one of the two reservoirs. We'll say the storage of water in the north reservoir is more important. We'll say to satisfy that 13,000 CFS minimum flow requirement, first we're going to empty out the south reservoir. And then if we can't satisfy the demand anymore, then go ahead and use the extra storage from the north reservoir after that. So let's go ahead and set that up and then see what it looks like. To do so, I'm going to go ahead and right click on our alternative and say new trial. And I'm going to give it a name. It's going to be called explicit north reservoir priority. Click OK. Can't see all the name, but that's fine. I'm going to go ahead and edit. And there's a few things that we need to do here. First thing is to click on reservoir systems right here. Then we're going to go through these menu items one at a time. First, we're going to create a reservoir system. So new system, I'll just call it reservoir system 1. Sure. Okay. And then the next one over is to identify which reservoirs are in the system. So edit reservoir set. I'm just going to go ahead and select them all, add, and then OK. So that's all we have to do there. I'll click apply and then OK. Oops. Okay. All right. So I have my reservoir system 1 set. Now I'm going to select system balance, new, and then this is the name of the system balance. I'll call it, um, I don't have a good names for these things, guys, so I'm just going to call it system balance 1. There may be, I mean, maybe like the zone would be important, but that's the next step. Okay, whatever. So system balance 1 is what I'm calling it, and then you would select the operation set for each reservoir. So each reservoir that we added to our system in the previous step should show up as a column down here, and it does. Okay, and then the last part is system zones. So we'll say new conservation zone, I guess. And then what we want to do below here is specify those priorities that I mentioned. So my priority was to go ahead and say the water and storage in the north reservoir is more important. So if we did that to an extreme case, we would say, so here's the north on the left and the south on the right. I would say, I would put these numbers in here. The user manual describes these as inflection points, and it probably does a much better job at explaining this whole explicit system storage balance than I'm doing here. So check that out. So what this table means is that if both reservoirs have zero volume, it's considered balanced. If both reservoirs are completely full, then it's also balanced up to the, yeah. And then also here, it's if the north reservoir is full, but the south reservoir has zero, then that's also considered balanced. So this is an extreme case, and let's give it a shot and see what happens. Also, I'm gonna identify the zone as conservation zone here, and I think that's all I need to do over here. So I'll click OK, and then over in the alternative editor, I'm gonna go ahead and click that, and then click on the operations tab, and now I need to define that system balance 1 as the storage balance for my reservoir system. Okay, let's save the alternative, close it, okay, and then run. Okay, so it ran. Let's see what the plot looks like. 1 second. Let's see what the plot looks like here. Let me zoom up. And something didn't work. Okay, what I'm seeing, this is the North Reservoir here. It looks like nothing happened. Just the South Reservoir, if we plot it. Okay, so the South Reservoir is doing its job. And I think I know what happened here. The reason is the South Reservoir is not completely empty. We were almost a little too aggressive with setting up those inflection points in the explicit system storage balance. What we're looking at here is an elevation of, it sometimes pops up, there it is, 1414 feet. So that represents a certain storage in the reservoir. Maybe it's 5%, maybe it's 10%, but it's not 0%. There really is a little bit of water still left in this reservoir. And because there's water left in this reservoir, then the North Reservoir is not going to help contribute to that required 13,000 CFS minimum downstream flow requirement. So what I want to do is look at the volume. So 1414, let's go ahead and check out the geometry real quick of the South Reservoir, which is the same as the North Reservoir. But if I click on pool, 1414 would be between 1410 and 1420. So that would be a storage of 2750 acre feet to 4100 acre feet. So if we split the difference, that would be about 3,400 acre feet approximately. And then so 3,400 into the guide curve is set to 1480. So that storage is 28, we'll say 29,000 acre feet. I'm just doing some mental math, and we'll just say 20%. I think that's a little bit high, but we want to be on the high side. Otherwise, we're going to get the same results as we did previously. So let's go ahead and make a few edits to our system operation rules here by going edit run and then reservoir systems. Now, like I said, this is too aggressive doing 100 and 0. So on the south side, let's just say 20. And then we'll add let's see, 20. And then we can go maybe 2020 and then 0, 0. Okay. So what this says is that when we need that extra flow from the network, from those two reservoirs, it's first going to use up to 80% of the storage in the south reservoir first. And then once there's no more water in the south, or once it hits 20% storage of the guide curve storage volume, then it's going to start using water out of the north reservoir. And then what's going to happen is a little bit, whatever remaining percent storage that can be used will be used from both reservoirs equally, which is basically the discharge between the 0, 0 row and the 2020 row here in this table. Okay, anyway, that was a little bit convoluted. I'm sorry. Apply, okay, and then okay. All right, let's go ahead and see what happens. Okay, so the simulation ran. Let's go right click and then plot. And then that's what I'm talking about. All right, so let me zoom in. And this is the North Reservoir. So what we see from the North Reservoir here is we have a constant inflow of 10,000 CFS, right? That's always been the same. Now what we have is the outflow from that North Reservoir is 10,000 CFS for the first 4 days, almost 4 days. And during that time, the South Reservoir is draining from 100% capacity of storage from the guide curve down to 20%. And then once it hits 20%, the north reservoir, because these reservoirs are in the same system, they have the tandem rule that's connecting them. And now it's time for the north reservoir to start releasing its 13,000 CFS. So in the south reservoir, I should see an actual flat line here representing uh, storage curve. Its elevation during these almost 4 days, and then at the end it empties out down to a constant 10,000 CFS. What's going on with these little spikes here? I can't explain it to you right now. I haven't got my head around it. I was just trying to get a basic example working. So we can explore that some other time. Let's check out the South Reservoir plot. And let me zoom in. Okay, I've zoomed into the South Reservoir plot. And what we see here is the inflow. So it starts at 10,000, so it's not getting any help. And during that time, the release is 13,000. And then, yeah, this is the flat part of the line because for those 4 days almost, we have an equal inflow and outflow of 13,000 CFS because it's just using that extra flow from the North Reservoir. And then, yeah, after about 8 days into the ninth day is when the outflow from both the reservoirs slowly approaches that 10,000 CFS outflow. And this flat line here is represents the 20% capacity of the guide curve for the south reservoir. Well, anyway, that was it for this exercise. Hopefully that you could take something away from that and understand how to create tandem release rules in HEC ResSim and the difference between implicit and explicit system storage balance.